Hello everyone, this is Asha Nashila. Today I want to discuss about the single linked list. What is single linked list? It is a collection of similar elements. Each element points to the next element. The linked list is a linear list of specially designed nodes where each node is divided into two parts, that is information field and next field. Here what is meant by information field? It contains necessary information about the items of the list to be stored and processed. The next field, it contains address of the next node. This field is used to access the next data item in other. So coming to here, let us take a small example. Here the 48, 17 and 142. Here I took the three elements. Here the header is pointed at the 48th element, and that is nothing but an information field. And after that, the next field is nothing but it stores the address of the next node. So what is the next node here? The 17 is the next node. That information is stored in the 40th element next field. So here for each and every node which it contains the information field and the next field. In the information field which it contains the elements, and the next field is nothing but it accesses the next data items. So what is the address of that next node? That information will be stored in the next field. Coming to the representation of linked list. Here in this, it may be a static or sequential or array representation. The linked list will be maintained or represented by two parallel arrays of same sizes. One array for the actual data items, it is called information field of the node, and the other array for the address called the next field of the nodes. So here information, here which it maintains the two parallel array of same sizes. One is for the information node and another for the next field of the node. So here 28, 8 and 24, these are the three elements are there. So 28 which it contains the header and 24 is the tailer. So end of the list. So in that end of the list, so here see here the cross mark is there, that is nothing but no information is there because that is the end of the list. So no address will be stored. Why? Because that is the end of the list. The second point is dynamic or pointers or linked representation. The size of the linked list may increase or decrease according to the requirements of applications. So dynamic representation of linked list do not have limitation and use space proportional to the actual number of elements of the list. So here dynamic or pointer or linked list means we can increase or decrease the linked list. We can increase or decrease according to the requirement of the application. So whenever we are inserting an element or deleting or we want to insert anything, means any element, so here we can increase or decrease the linked list. So we can call as a dynamic representation of linked list. We do not have a limitation and use space proportional to the actual number of elements of the list. Coming to the features. It wants ultimate size of the linked list to declare in advance. Array implementation of the linked list is very simple and efficient in random access of the elements. These are the two features. Then coming to here, operations on single list. So here creating the linked list. In this, to create a linked list, we have to maintain the list of free nodes in array implementation. The list of free nodes, and those initially all the nodes are empty and linked to one another in sequence. The next field of the last node contains the -1 to indicate that is the end of the list. So here first of all, to creating the linked list, first of all it has to maintain the free nodes in the array implementation, and also the initially all the nodes are in empty and they have to link to one to another in sequence, and the end of the last node it must contain the -1 in the information field. So in the next field, not in the information, in the next field, the last node must contain the -1 because we have to know that is the end of the list. In this way, we have to create the linked list. This in the traversing a linked list, this operation is used to visit each one of the list exactly once in order to access the information stored in nodes. Coming to the algorithm, start is equal to null. If start is equal to null, means the list is empty. Null means the list is empty, exit. And if, close the if condition. Next, PTR means pointer. PTR is equal to start, and we have to repeat the 4 and 5 until the PTR is not equal to null. So here the 4 and 5 steps are access and apply PTR to information. So information field. So whatever the elements we are taking, that we are accessing, and set PTR is equal to PTR to next. So here the PTR is equal to PTR tends to next is nothing but in the next we are storing the address of the element. So end, the process is end, the repeat until whatever the elements are there, those process will be repeated until the PTR is not equal to null. This is the general process of the linked list. This is the algorithm representation. Now we will see how to insert an element into the linked list at various positions. Generally we have 3 positions. Header, or at the beginning we can insert the element, or at the end of the list we can insert an element, or at the specified position we can insert an element, right? So insertion of node into a linked list requires a free node. First of all, if you want to insert an element, we have to insert a node, means that is a free node in which the information can be inserted, and that node can be inserted into the linked list. So we have the 3 ways. Header, at the starting position we can insert an element, at the end of the list, or at the specified position. Now we will see insertion at beginning. So I took an example like 48, 70 and 142. These are the 3 elements, and 48 is the header and 142 is the end of the list. So in that next field, here I am storing the -1, that is nothing but that is the end of the list. So here I want to insert the element like 93. First of all, what I have to do, step 1, I have to take a free node. In that free node, I have to insert a new element like 93. Here I am taking a 93. The first step is I have to insert a free node. I have to take the free node. In that free node, I have to insert a new element 93. And here I am inserting the element at the beginning, or header. So what I have to do, simply I can insert I have to remove the header at the element of 45, and I have to insert the node, and after that in that node I am specifying the element, means information, and after that in the next field I have to store the previous node address. So 48 address I have to store in the previous node. So this is the insertion at beginning. Now coming to the insertion at end. The same example I took, and at the 142, after the 142 I have to insert an element 93. So first of all I have to create a node. So after that I have to insert an element 93, and after that I have to remove the end of here. I have to remove the -1, and I have to insert the whatever I want to insert the element, that element address I have to store in the previous information field. And here the 93 address is stored in the 142 next field information. And here after that 93 is an information node, and in the 93 there is an next field. In that next field I am replacing with a -1. So here 90, after the 93 there is no node will be there. That is the end of the list. So in that way, insertion at end in the single linked list. The next one is the insertion at the specified position. So if you want to insert an element or insert a new node at specified position, we have to search the position in the list. So where we have to insert that particular element. So then we can insert that node after the position. Let that address of the specified node be kept in the PTR. So first of all, if you want to insert in a specified position, at what position if you want to insert an element, for that we have to store the we have to store the specific address before element specific address in the specified pointer and adjust that pointer. And after that the next point of the specified node pointed by the pointer. So in that way we have to store the address of the particular node information. We have to store in the pointer. And after that while we are inserting the node, for that node again we have to adjust that pointer. So in that way the next pointer of the specified node pointed by the pointer. So here we can see the diagram representation for this insertion at the specified position. So here I took an example, the same thing, 48, 17 and 142. These are the three elements. 48 is the header. So here first of all, while I have to insert the element in the specified position, so first of all I have to create a node, and I am inserting the element in that particular node. See here I want to insert that in between the 17 and 142. So for that whatever the information is stored, the address is stored in the next field, that information will be stored in the pointer, and after that the node will be inserted. And here after the node is inserted in the specific position, so after that we have to adjust the pointer. So 142 address will be stored in the 93 next field, and 93 element address will be stored in the 17 information field of the next. In the next field the 93 is stored in the 17th element next field node. So in that way we have to insert the element in the specified position. Simply we have to store the particular address in the pointer, and after that we have to adjust the pointer while we are inserting the node in the specified position. So in this way we can insert at the beginning or insert at the end of the position, on inserting at the specified position. Coming to the deletion an element from the linked list. How to delete an element? Here also we have the three steps. Deletion at the beginning position of the linked list, at the end position of the linked list or at the specified position of the linked list. Just it is same as the insertion. How the insertion is going on in the linked list, the same process will be at the deletion also. Here, if the node be deleted, the element should be searched all over the list till the node find. Then it should be deleted. Clear? So coming to here, deletion at the beginning. So whatever I inserted the elements here, 93, 48, 17 and 142. Again I want to remove at the header. So 93 I want to remove. So simply I can select that and simply I can remove that. So whenever the 93 element is removed, so automatically the header moves to the 48. This is the deletion at the beginning. Coming to the deletion at end. So here, first of all I have to know which element I want to delete it. So here 93, I want to delete the end of the list. The element is 93. So simply I am deleting the element. So while I am deleting the element, the 93 address will be removed, and at the 142, that is the end of the list. So in that next field node, which it contains the -1. Here in the 142, the address will be stored in the -1. So simply we can say that that is the end of the list. Deletion at the specified position. So here in this I want to delete the 93, right? So in 17 and 142, the 93 is placed. Suppose if I want to delete the 93, the same process here, I have to select that, and after that the address will be stored in the pointer. So whenever I am removing the 93 element and that pointer is accessed, and which it is the 142 element is stored in the 17 element next field node. So in that the 142 address will be stored in the previous next field address. So this is the deletion of the at the specified position. So it's clear how to create the element, how to insert an element at the header and at the end of the position and at the specified position, and the same process will be done for the deletion of the beginning and the deletion of the end of the list and also at the specified position. Okay, thank you.